Hello everyone. So this is the fourth part of the video. Let's start with the topic type of motor uses in electric vehicle. So there are total 5 types of motor uses in electric vehicle. Let's start with the first type, DC series motor. High starting torque capability of the DC series motor make it a suitable option for the traction application. It was the most widely used motor for the traction application in early 90s. The advantages of these motors are easy speed control and it can also withstand a sudden increase in load. All these characteristics make it an ideal traction motor. The main drawback of the DC series motor is high maintenance due to brushes and commutator. These motors are used in Indian railways. These motors come under the category of DC brush motor. Let's see, the second type is a brushless DC motor. It is similar to the DC motor with a permanent magnet. It is called a brushless because it does not have the commutator and brush arrangement. The commutation is done electromechanically in this motor because of the BLDC motors are maintenance free. BLDC motors have a traction characteristic like a hard starting torque, high efficiency around 95 to 98%, etc. BLDC motors are suitable for high power density design approach. The BLDC motors are the most preferred motors for the electric vehicle application due to its traction characteristic. BLDC motors further have two types, outrunner type BLDC motors and inrunner type BLDC motor. Let's see the outrunner type BLDC motor first. In this type, the rotor of the motor is present outside and the stator is present inside. It is also called as a hub motor because the wheel is directly connected to the exterior rotor. This type of motor does not require external gear system. In a few cases, the motor still has a inbuilt planetary gears. This motor makes the overall vehicle less bulky as it does not require any gear system. It also eliminates the space required for the mounting the motor. There is a restriction of the motor dimension which limits the power output in the internal configuration. This motor is widely preferred by electric cycle manufacturers like Hulaikel, Throngs, Sparrow, light speed bicycles, etc. It is also used by two-wheelers manufacturers like 22 Motors, NDS Eco Motors, etc. The second type is inrunner type BLDC motor. In this type, the rotor of the motor is present inside and the stator is outside like conventional motors. This motor requires an external transmission system to transfer the power of the wheels because the outer runner configuration is a little bulky when compared to the inrunner configuration. Many three-wheeler manufacturers like Goneka Electric Motor, Spigo Vehicles, Kinetic Green, Volta Automotive uses a BLDC motor. Low and medium performance scooter manufacturers also use the BLDC motors for propulsion. It is due to these reasons it is a widely preferred motor for electric vehicle application. The main drawback is the high cost due to permanent magnets. Overloading the motor beyond a certain limit reduces the life of the permanent magnet due to the thermal condition. The third type is a permanent magnet synchronous motor, PMSM. This motor is also similar to the BLDC motor, which has a permanent magnet on the rotor. Similar to BLDC motor, this motor also have a traction characteristic like a high power density and high efficiency. The difference is the PMSM has a sinusoidal back EMF, whereas BLDC has a trapezoidal back EMF. Permanent magnet synchronous motors are available for a higher power rating. PMSM is the best choice for a high performance application like cars, buses. Despite the high cost, PMSM is providing stiff competition to the induction motors due to increased efficiency than the latter. PMSM is also costlier than BLDC motors. Most of the automotive manufacturers PMSM motors for their hybrid and electric vehicles. For example, Toyota Prius, Chevrolet Bolt EV, Ford Focus Electric, Zero Motorcycle S/SR, Nissan Leaf, Hyundai Accord, BMW i3, etc. uses PMSM motor for propulsion. The fourth type is the three-phase AC induction motor. The induction motors do not have a high starting torque like a DC series motor and a fixed voltage and a fixed frequency operation. But these characteristics can be altered by various control techniques like a FOC or VF method. By using this control method, the maximum torque is made available at the starting of the rotor, which is suitable for the traction application. Squirrel cage induction motors have a long life due to less maintenance. Induction motors can be designed up to the efficiency of 92 to 95%. The drawback of the induction motor is that it requires a complex inverter circuit and a control of the motor is difficult. The last type of the motor is the switched reluctance motor, SRM. Switched reluctance motors is a category of variable reluctance motor with a double silence. Switched reluctance motors are simple in construction and robust. The motor of SRM is a piece of laminated steel with no windings or permanent magnets on it. This makes the inertia of the rotor less, which helps in a high acceleration. The robust nature of the SRM makes it suitable for the high speed application. SRM also offers high power density, which is same required characteristic of an electric vehicle. Since the heat generated is mostly confined to the stator, it is easier to cool the motor. The biggest drawback of the SRM is the complexity in the mode control and increase in the switching circuit. It also has some noise issue. Once SRM enters the commercial market, it can replace the PMSM and induction motor in the future. We will see the next topic in the next video. Thank you.